All right, we're looking at section 33.2, cylinders and cones. A cylinder is a set of all points in a space that are given distance, a radius, from a line known as the axis. So here is our axis. All these points on the outside and that kind of go around to the front, we can't tell, are the same distance away. So it's a bunch of little circles that stack up, with the axis being the center of those circles. So that is our axis. And because the axis is perpendicular to the base, both bases, it is a right cylinder. And right basically just means it stands up straight, and that's what we're going to see in future chapters. So label the axis. We have our radius, which is just the radius of the two bases, which is our circle. Another radius here. And the height, the axis, or the side here, both the same. So pretty straightforward. Our perpendicular distance from base to base, where our bases are circles. Describe the shape and size of the cross sections that are parallel to the bases. So if we cut across parallel to our bases, then we have circles. So we cut straight across that are congruent to the bases. An oblique cylinder means that our axis is not perpendicular to our bases, so it's not straight up and down. It's a better way to draw it. Something like this, where this is our height. That would be oblique. And again, perpendicular, our height. So we still have all the same measurements we had before. We still have a radius. And our axis would be here. It's not perpendicular to the bases. That's oblique cylinder. Len is working on a pattern for a right cylinder. Which base is the correct size for the cylinder? So we were to wrap this rectangle around the circle. So this length, we'll call this length, has to be the same as the circumference of the circle. Now, this circumference, while the diameter is about 1 centimeter, I measured it. Here it's about 0.75 centimeters. So the circumference is 75 pi, which is about 0.3 centimeters. Whereas this circumference is, well, 1 pi, which is about 3.14 centimeters, and this length is about 3 centimeters. So the correct one is this circle. That would be our base. Explain how the dimensions of the rectangle and the net item relate to the cylinder once it is constructed. So again, the length of the rectangle equal to the circumference of the circle base. So this is L. This circumference is L as well. And our height there, the height of the rectangle, is the height of the cylinder, or the distance between bases, the circle bases. Now if we look at a cone is basically the same thing as a cylinder, but instead of a base on one of the sides, we have a vertex. That's what this says. We still have our axis, and if it's perpendicular and it goes through the center, it is a right cone. And a radius is just like it was on the other one. Our height, again, is perpendicular distance. So this is the right cone, This is an oblique cone because the height does not go through the center. And this is an oblique cone as well. And this is an oblique cone because our height does not go through our center. So also with these, our axis is bigger than our height, larger. This distance is more than the height. This distance is more than the height. Compare and contrast the shape and size of the cross sections of a right cone that is parallel to the base with the cross sections of a cylinder that is parallel to the base. So if we cut it across in a cylinder, all the cross sections are congruent. In a cone, they're congruent circles here. In a cone, all cross sections are circles, but decreasing in size as we reach the vertex. We're talking about the cross section of a right cone that is perpendicular to the base, so going up and down. So a side view, really, it is an isosceles triangle because these sides are the distance around of the cone. They're all the same distance. And my base looks flat if I completely just cut it in here. And again, this is my vertex of the cone. It's also the vertex of the triangle. When the tent business gets low, Len makes lampshades, which are formed when a plane parallel to the base intersects the cone. So we intersect it parallel here, and we cut off the top cone, making this lampshade. Len knows the height of the cone is 30 inches. So this is 30. He needs to know the area and the circumference of the smaller circle, which is the top of the shade, this distance. Assume the cross sections are 20 inches apart. So this is 20, so this would be 10. All right. So label the center of the small circle P. Draw in PQ. Identify two similar triangles in the figure. So what I'm going to do is kind of a cross section perpendicular to the base. That looks like this. VPQ and VCA. That's what this is. If we look at directly on the side, we do a cross section perpendicular to the base, through the center, through the vertex. So cut it completely in half. Why are these triangles similar? Well, because our bases are parallel, and this is a right cone. We know these are right angles, and these angles are congruent because there are corresponding angles. So if parallel lines, corresponding angles are congruent. Or angle V is congruent to itself, and the right angles. Either way, those two triangles are similar by angle. So that's triangle VPQ is similar to triangle VA by angle similarity. Let R represent the radius of the small circle. So PQ is R. Using corresponding sides of the similar triangles, write a proportion and solve for R. Here's R. We know this is 20, 10, and the radius of the big cone is 9, or the cone is 9. So 10 over 30, the whole side is equal to R over 9. So our radius, when we solve for that, we cross multiply and divide, r equals 3. Find the circumference and area of the smaller cross section. So this circle, so that's what we've been doing. Area pi r squared. So in this case, 9 pi inches. For circumference is pi r, so 6 pi inches. Now the rest of this is going to be your homework. Hopefully we took some notes and we know what's going on here.